Hello, beautiful people. Today we're going to be talking about 5-2 direct variation, also known as direct variation. Depends on who you're talking to. Your SWABAT is going to be to write and graph an equation of direct variation. A little bit of vocabulary. Direct variation. A relationship can be represented by a function in the form of probably a highlightable, or if you don't have a highlighter, I will at least kind of bubble this in. But make sure that you have this key thing. There you go. Y equals kx. Y equals kx, and k cannot be 0. The constant of variation, another thing to remember, is going to be called k. Not k for constant, because constant starts with a c, but k for constant with a k. Two things to try to memorize, but if you don't remember this one, not that bad, because we will always have this in our back pocket. Y equals kx. I'm going to say it like 5, 3, 6, 7. I don't know. You count. That was like 3 already. Y equals kx. Don't forget it. Okay, example number 1. Determine whether the equation represents a direct variation equation. If it does, find the constant of variation, which we call k. Okay, in order for it to be a direct variation equation, it has to be of the form y equals kx. So the first thing I want to do is get y by itself, if you could please. So for those of you that don't remember, let's subtract 3x and subtract 3x, and I have 4y is equal to negative 3x minus 5. Y is not alone, and I do need it to be, so I'm going to divide everything by 4. And I have y is equal to negative 3 over 4x minus 5 over 4. Let's go back to this. Y equals kx, period. It doesn't say kx plus 10, kx minus 3, kx minus 5 over 4. So because of this, we can say it is not direct variation. Okay, what was the first thing I did for part A? First thing I did was to get y by itself. So let's do that. I have negative 36y, so I'm going to divide by negative 36. Divide by negative 36. I can reduce this fraction because 12 goes into 12 one time. 12 goes into 36 3 times. Is this direct variation? Y equals kx. Y equals negative 1/3 times x. It's not plus anything. It's not minus anything. So yes, it is direct variation. I'm going to say yes. And what would your constant of variation? That's the k. K is whatever number or coefficient is in front of the variable. So k is negative 1/3. Your constant of variation is negative 1/3. Okay, let's do the same thing here. Looking at this equation, what do I need to do to get y by itself? Very good. Add 12. So y is equal to 12x plus 12. Direct variation equation, yay or nay? Yes or nah? Nah, because you have the plus 12, so I'm going to say no. There you go. Alright, scroll down with me here. Suppose y varies directly with x. Okay, if that's true, then I can say y equals kx. That's just from this sentence right here. Write a direct variation equation. Okay, I'm going to stop there. I'm not going to not going to read that part yet. I'm just going to stop here. Write a direct variation equation. So y equals kx. Y equals kx. Y equals kx. I told you I was going to say this a million times. I didn't lie. So instead of y, they told me y is 6 equals k, I don't know, but x is 18. Well, let's solve for k. Okay, that's 1/3 equals, that's like my favorite fraction today, it looks like. 1/3 equals k. Okay, so my direct variation equation, y equals kx, y equals 1/3 x. I just want a relationship that relates x and y. So y is 1/3 of x. Whatever x is, y is 1/3 of it. Just like whatever my height is, there's a couple students, it's always going to be 1/3 of it. Won't mention any names. Okay, so that's part 1 that they asked me to do. Check, I'm done. But then they said, then find y when x equals 8. I can do that. So when x equals 8, y is equal to 1/3 times 8. Y is equal to 8 over 3. Two answers for this problem. 1, 2. Okay, let's try another one together. Won't leave you yet. Y equals kx. Write my direct variation or direct variation equation. So 2 equals kx, which is 5. Divide by 5, divide by 5. 2 over 5 is equal to k. Not always a fraction, but this time it is. So what's my equation? Y equals kx, 2 over 5x. One of my answers done. The next thing, and you can do this if you'd like to on your own by pressing pause and then unpause when you're done to check it with me. Y equals 2 over 5x, which for me is 8, because then find y when x equals 8. So the value of y when x is 8 is 16 over 5. Very good. Okay, a little decimal action there. If you're feeling brave, and I know some of you are, and I love you for it, go ahead and try the next one. If not, stay with me. I don't mind you tagging along. Okay, 9.92 equals k times 12.8. Same process, it's just a decimal. Divide by 12.8, divide by 12.8. And then if you have a calculator, now would be a great time to use it and pull it out. If you don't, you're probably just going to copy me. And you're going to get 0.775 is equal to k. So y equals 0.775x. Part 1. Next thing, now you can do this though without me. Y equals 0.775. X is still 8. So when x is equal to 8 for this direct variation equation, y is equal to 6.2. And there you have it. Okay, this next part I've taught different ways. Oh, if you need to, go ahead, press pause, and then scroll down with me. But this is what I do like. Direct variation, here's a given. So you have a graph, and you're going to pretend like those lines are straight. And no matter what, direct variation equations always, because it says there always, big, bold letters, always goes through the origin, which is right here. Always goes through the origin. No matter what line it is, oh, that's a horrible line. Always goes through, here's how we'll fix it. Always goes through the origin. Just make it bigger. Always, Miss Fitzgerald, always goes through the origin. So no matter what the line looks like, it will always go through the origin. Yeah, every line I make here seems to just be getting worse. Always goes through the origin. This is why, great point right now. Good idea right now, go ahead and press pause and get yourself a ruler if you don't have one out right now. Do that. Go ahead, press pause, do it, grab it. Okay, so one thing I just said, it always goes through the origin. I promise you, my lines are going to get better. I promise, it'll get better. Let's try. So if it always goes to the origin, it's always going to go through this point. Now, this k value, what's the k for this equation? Y equals kx. Well, my k is equal to 4. K is going to be most useful for me as a fraction. I know, normally you hate them, but right now you're going to love them. Because remember from the previous lesson on slope, we learned that the slope is rise over run. Here's a beautiful part of your day. K and slope are the very same thing when you're graphing. Period. Same thing. It's going to make my life a million times easier because I'm not going to make you make an XY table for this. Nope. I'm going to let you use, yesterday we used the slope triangle to figure out like what the slope was, like the rise over the run. This time we're kind of working backwards where I'm going to start here and remember the top number, that was your rise over your run. They're directions. So this 4 on top is telling me to go up or down? Up, because it's positive, up 4. This 1 at the bottom is telling me to go left or right? Right, because it's positive. So from this point, and I'm always going to start at the origin, I'm going to go up 1, 2, 3, 4, and right 1. What if I wanted to do more? I can move the opposite and go down 1, 2, 3, 4, right, left 1, down 1, 2, 3, 4, left 1, but I really only need the 1 point. Okay, from here, use your straight edge, beautiful people, and let's pray that my line gets better. And so it did. I did promise you. Wow, I don't know what just happened there. Just went where I didn't want to go. There we are, back to where we need to be. There you go. So y equals 4x. Put a label on that one because you need to. Okay, part B. What do? Well, looking at it, what's your k? Your k is 2 over 3. Remember, it's rise over run. So this is rise, so that means I'm going to go up 2 and right 3, because this bottom number tells me to go left or right. Well, that's great, but where do I start from? Always going back there, start at the origin. And then from there, up 1, 2, right 1, 2, 3. I can stop here and just connect them. Or what's the opposite of going up 2 from here? Down 2. What's the opposite of going right 3? Left 1, 2, 3. Opposites work too. Sometimes. Not in every relationship, but sometimes they work out. Alright, and did my line not get better? Yes, it did. Okay, so y equals 2 over 3x. This whole thing over here is a whole thing of a past. We're moving on, onward and upward. Okay, so we can now turn your paper over if you don't mind. This is going to be a 2-lesson thing. I can kind of feel it, but it's fine. So what do we have here? An equilateral triangle is a triangle with 3 equal sides. Equilateral, if that makes sense, equal. The perimeter of an equilateral triangle varies directly. That's important to us. The perimeter, P, of an equilateral triangle varies directly. That's keyword. With the length of one side. Okay, what that's saying is that P is going to equal to something, that's the K part, times L. Something. What is an equation that relates P and L? L is the length of the side. And then what's the graph of the equation? Alright, so let's check this out. Let's say that we know, and we do, that the perimeter is equal to the sum of the sides. Well, in an equilateral triangle, they're all the same. It's just going to be an L plus another L plus another L, because all the sides are the same. Oh my gosh, it's a horrible triangle. So L plus L plus L, P equals 3L. So what's the K in this situation? Well, it looks like the K equals 3, because it's 3 times the length for every perimeter. Okay, so let's make this, instead of X, it's going to be L, and then this is your P. That's a beautiful thing. And then what? Well, if I have 0 sides, I'm going to have 0 triangles. What if I have 1, 2, 3, 4, and 5 here? And then for the other side, let's think about this. My perimeter, because like when it's 1, it should be 3 for my perimeter, and then it'll be 6, and then it'll be 9, then it'll be 12, and then it'll be probably 15. So if I have one triangle, I'm sorry, if I have one line, if the length is 1, I'm having a brain fart. If the length is 1, then the P is 3 times 1, which is 3. If the length is 2, then the P is 3 times 2, which is 6. Okay, if it's 3, 3 times 3 is 9, then 4. Thing is, though, you can have half units for this one. Like, I can have half of an inch for the length, and then I would be here instead. So I am going to connect these dots. But I won't go into the negative side, though. Okay, I'm almost up to my 15 minutes. So I'm going to go ahead and press pause here. I'll see you for part B and the rest of this sheet on the next video. Thank you so much.